Google at the Munich office there, and yeah, I'm going to tell a bit about automatic formatting for C++. So first of all, why do we want to do automatic formatting? We think that a consistent style is very important. I don't know whether anyone here disagrees. Just show your hand. Okay, so do you work on a bigger project? Right, with multiple people contributing, right? So yeah, a consistent style is important, but unfortunately, formatting is very tedious, right? Like across the Clang code base and probably also across the LLVM code base, we have about 25% white space characters, right? So even if you look at this, this simple function, we have a whole lot of white space characters in front here, right? Now you can argue that most of these white space characters you don't have to type yourself, right? Any halfway decent editor will, whenever you press an enter after the comma, will just insert all the white spaces for you. Right? But then at one point you might want to rename the function. So instead of classify name, you want to name it classify some name. Right? And what happens is that you have to add white space to all these little parameters. And then even that probably an editor could do for you, but then at one stage you actually see that the last few characters of the last parameter don't fit in the line limit anymore, and you will have to reformat everything. Right? And at one point most editors will give up. Right. And that's why we build Clang formats, so actually they can still do that all of that for you. So you never have to type space again, basically. There's more reasons why we need a Clang format tool, and that is basically we waste a lot of time in code reviews. So whenever you go to the LLVM commits mailing list, just search for space. I think you'll probably on any given day find an email looking like this. So somebody sent a patch, and somebody else replied, well, we need a space after the while, and we'd never ever put spaces inside parentheses, so please fix that. And we have a lot of time wasted by just the person submitting the patch, the person replying, please add spaces here, and then follow our patch. Right? And that's just a waste of time. We don't ever want to do that. And the third reason why we really need automated formatting is so that source files become machine editable. Right? So we've heard about source-to-source transformations just now, and another example is the C++ 11 migration tools. They are part of the tools extra repository in Clang. And what they do, for instance, like one step of what they do is they transform simple for loops, for instance here, a sum over all the elements of an array, into range-based for loops. Right? So they end up with this for loop. Now, if you just blindly do that, you always end up with inconsistent formatting, right? And even with this very simple example, you have a huge number of places where you can screw up the formatting. Right? So the first is we use a reference here for iteration element. And depending on your coding style, you might either want that with a type or with a variable, right? And the migration tool can't just easily decide that. Then you have an array, and that might have a very long name, so it might actually not fit into your column limit, like if you have a column limit. Right? And then for the loop body itself, like some people like to contract it to a single line if it fits. This expression might be very long, so it might actually need to be split differently depending on the element name and what it used to be before. So even in this very simple example, you have a huge number of places where you can mess up formatting. So when you want automated source-to-source translation tools for human maintainable code, you need to format them afterwards. Right. So that's why we want to build Clang format. So how did we go about it? So once we made the decision we want to build it, how did we do it? So first we set up a design document outlining everything we thought was important for building Clang format, and then we sent that to CFE-Dev. I think this process is kind of important because it works quite nicely. And we gathered all sorts of feedback and actually got a lot of new ideas that we didn't have before, and that was very helpful. And basically now the design doc, you can still look it up, it contains basically 5 key questions. First of all, we decided that we want to do indentation as well as line breaking. So a lot of editors can re-indent a source file nicely for you, but without actually changing the line breaking as well, that doesn't help much as an automated formatting tool. Then we want to use Clang format both as an editor integration as well as for other library tools, so as a library, as I showed with the CPP 11 migration. Then we sort of made the decision that at first we only want to change white space characters because that's actually a safe transformation most of the time. Right? So if you only change white space characters, unless you do it in particularly bad places, you usually don't change the program behavior. Then there's a bit of a discussion of whether we want to build based on Clang's parser, so using the syntax tree, or just using Clang's lexer, and I'm going to go back to that in a bit. And we discussed that we probably want to deduce a bit of the style from the input source file, so that whenever you change something, you are consistent with the local style, because consistency is really what's most important. Right? And then we started out and implemented it, and we actually, for most of this stuff, we actually did sort of what we intended, and for some things we did something completely different. And we actually didn't capture many of the problems that occurred quite well. So we actually discovered we had a whole bunch of completely different problems when implementing it. So, as I said, how did we build Clang format, or what's the key part that we built upon? And we basically have the decision of going with Clang's lexer, building a token stream, or building, like using Clang's token stream, or using the parser, and thus the full syntax tree information. And we were very convinced when we started out that we have to use the parser, but then we tried to start out with just the lexer. And here's basically the reason why. So you have here a simple piece of C++ code that's taken somewhere from Clang's code base. And who among here, like show of hands, who among here thinks that with a reasonable amount of time could end up with a formatting like this? That looks kind of nice, according to some style guide. I can. Like 3 or 4 people. It's not that hard. You need like 2 after open brace. Okay, who thinks he cannot format this source code? Okay, so everyone can. Now, who among here thinks he can build, or with a reasonable amount of time, write down a syntax tree for this piece of source code?
There is.
Right. So without, like, obviously it's a trick question like this, like if you don't ever invoke this macro, there's no syntax tree for it. Right? If you invoke the macro, you can create a syntax tree, but that might actually look quite different. Right? And we still want to be able, like, independent of whether we find a call site of this macro or just find only this in a header file, we want to be able to format this nicely. Right? Because especially in macros, it gets particularly hard, like with these escape new lines, it gets particularly hard to keep up nice formatting. And then we thought, well, if we want to do that, then we might as well try to just live with Alexa everywhere. Right? And also the Alexa is basically what's actually contained in the source code, right? The parsed syntax tree is what, like after the preprocessor happened, what the compiler sees, but what the human sees is basically the Alexa. So we tried and start out just using Alexa. So what's the architecture we use them? We basically have a few key elements. So the source code that we use as input is first put into a structural parser. And this structural parser basically tries to subdivide these, the source file into what we call unwrapped lines. I'm going to get back to that on the next slide. After that, we put these unwrapped lines into a token annotator. And this token annotator basically tries to calculate the extra information that we don't get from the lexer. Right? So if we have a star here, that might be a multiplier, that might be an address of operator, it might be a pointer. Right? And the token annotator basically tries to know that from just the line. And we might at any point, if we see we really can't live with Alexa alone anymore, we can replace that or add to that the syntax tree information. And then we put all these lines into the layouter, and the layouter then nicely breaks lines, removes spaces or adds spaces as needed, and then combines the lines back together into the output file. So unwrapped lines, kind of an ugly name. We really couldn't come up with a better one. It's basically everything we would want to put into a single line if we didn't have a column limit. Right? So if we had infinitely long lines, we wanted to put anything, like everything on one line. That's an unwrapped line. Another key aspect of that is that the formatting of one unwrapped line does never affect any other unwrapped line. Right? So that basically nicely divides and conquers our problem. But actually it's not quite that easy because, well, we have C++, right? So this is a valid C++ code, I think. You have a function. Inside the function you have a function call, and inside the function call, just right in the middle you decide to define a macro. Right? Don't know why you would. Yeah, don't ask, but these things happen in real code, and they actually make sense at some point. This doesn't, but you find cases where it does make sense, right? And so we actually take that into account. So what we do, we build 4 unwrapped lines out of this, I think. One is basically the function header thingy. One is the function call with the complete line with sort of an annotation that it's split at some point. And one line is the macro definition, and then the closing brace is the last line. Now it's not like we don't have a fixed order in this then anymore, like an easy trivial order anymore, but we actually create those lines in it. Right. And nothing you can do within the formatting of this unwrapped line will influence in any way the formatting inside the macro. So that's basically possible. Now we get to maybe the most intricate part, the layout itself. When you have a longer statement or longer function call or whatever, you actually can come up with a huge number of different ways to actually format them. So this is one of our test cases. You have a long function call with several parameters. And basically what we do is for any given break, we assign a penalty. So we have 3 line breaks here. We assign 3 different penalties. And the total penalty of sort of this layout of this function call is then just the sum of all the individual penalties. And how do we come up with these penalties? Now there's a variety of factors that go into that. There's the nesting level, so we try to break at higher AST nodes basically. We have token types, operator precedence, and all sorts of different stuff. Now how do we determine the best formatting? Well, we simply find the one formatting with the lowest penalty. Right? So for that, basically all we have to do is we have to try all combinations and then select the one with the lowest penalty. But funnily enough, that's actually kind of a hard computational problem, right? Because Clang format can basically split or not split at any given token, right? Even if you optimize that a bit and say you never want to break before operators, for instance, you still end up with 8 different split points. This is a very simple example, right? Which then means you have 256 combinations just for like this one line, right? And you can easily come up with valid, like real life code that has millions and millions of combinations which you can't easily just compute. Right? And we solve that by using memoization, using what we call an indent state. So basically on any given time during, like while you try to format a line, you have consumed n tokens, are currently in column m, which is usually quite small because you have a column limit, right? And a few other things. And basically when like nothing that happens, no matter what happened until then, the penalty for the rest of the line will be independent, will be the same, right? So we don't need to compute that twice. And that actually brought us quite far. So we started with really an exhaustive search just with memoization. And by now we have realized that it actually, like all these different indent states actually form a graph, right? So whenever you add a new token, you basically add an edge to 2 new nodes. And with the cost function, you have a certain cost for each edge, and then you can just find the cheapest sort of state path with Dijkstra's algorithm, right? And then just try to find a way from having not formatted any tokens to the end of the line that is cheapest, right? And with that, we actually can format everything quite quickly, and still be sure that we found the optimal solution. Okay, now that we've solved all the hard parts, all the easy parts, we could actually get to the more important problems, right? You laugh. Really, people get much more angry if you do this wrong than anything else we can do wrong, right? So some people think the pointer goes with the type. Some people don't think the pointer goes with the variable. I don't care at all. I just want it to be consistent, right? So what we have done, and that's also what we set out to do, and this is basically, but the only thing we've done so far is that we actually do this can do this adaptively. So Clang format can, before actually doing anything, can look at the source file, figure out where all the pointers and references are, and see whether there's a space before but not after, right? And it can count all these cases, take a majority vote, and then you end up with the code that is consistent with the rest of the file, at least as consistent as you can be. Right. So let's go to some examples and then do a quick demo. I just picked these examples randomly, right? There's a lot of stuff, like a lot of individual things that we have looked at and tried to come up with what people mostly do. But I think for loops are actually quite interesting. Here's a few different ways, just a few different ways of how you could actually format a for loop, right? Interestingly, they are all taken from CMA.cpp, right? so that much for consistency, right? So you can basically just break at the earliest point. You can sort of try to align the two loop variables, right? You can try to align the equals, all sorts of different things. And I'll show what Clang-Format does in a minute. What's also quite interesting, I think, is expression indentation. Right? So if you have a more complex expression with parentheses, it's quite easy. Right? So here I've just added parentheses that would all be unnecessary. Right? So it's always the innermost binary expression is parenthesized. Right? And then it's actually quite easy. So we just align everything, like all the parameters, with the parentheses. But the question is, how do we indent this if we don't have parentheses? Right? And we basically thought, well, we should actually lay out it the exact same way. So we just remove the parentheses for now, right? So you can now, as you can hardly see it, we actually thought, well, one space is a bit not enough, so we actually use 4 spaces where parentheses was before, right? So you end up with code like this. Looks a bit weird, but actually helps a lot. So if you find or use any given binary operator here, you just have to look at the right-hand side. And the right-hand side extends to basically until you reach a higher, lower indent level, and the left-hand side reaches to also when you find a lower indent level, but including, right? So for any given operator here, you can just look down until you find like something in the same column and then ignore it. So this is your right-hand side, and you can go up and basically take everything up there, like including the one that you hit. Luckily, this is not a very common problem, right? If these things can become more complex, people add parentheses, and I'm very happy about that. But we also have to take care of the people that don't, right? Okay, demo time. So, as I said, I think it's very important that we integrate Clang-Format good with all editors. I obviously use VI because it's like the best editor, but we also have integrations for other editors. And what we have done is Clang-Format is used as a binary, and we just have sort of a small integration script that you can download. Oh, awesome, thank you. A small integration script that you can bind to a key. It's like a 2-line Vim configuration, and that will set you up like this. Right? So I've bound Clang-Format to Control K, and then we'll just format the current line or the current selection. Right? So here's one of the for loops that I would not format like this, and Clang-Format wouldn't either. So I hit the button and it will format it nicely, right? So Clang-Format actually decides to align the variable names of the for loop and sort of insert line breaks so stuff doesn't get hidden here, and that's what it does, right? Here, same thing. You just hit the key, and it will always indent a bit, right? Because without indentation, it looks a bit weird. And you can, of course, just select a bit more code and then format all of that. Right, and now the for loops are more consistent than they were before. I'm not arguing that any of the original formattings was particularly bad, but if you change them within a file so rapidly, then it just becomes much harder to read, like at least for me. Here's the next example we had. So this function call is split around the macro, right? If I hit Clang-Format just on the function call, it would format the function but not the macro, right? It does all of that in memory, so you can just press undo and it will undo everything, or at least the last operation. If I just format the macro, then it actually formats the function around it because it's also in the function at that point, right? So, but you can see that it does the right thing. It aligns it with a parameter. I can add something here. It will shift the parameter around, right? It also does, we have actually had a lot of questions about Objective-C, and it was actually quite easy to also support Objective-C, right? So this is an Objective-C call. I personally don't know anything about Objective-C, but I was told that this is nice formatting for it. We also have Objective-C declarations, also works quite nicely. We do stuff like aligning comments, right? So they don't get mingled with other stuff. This is the expression we had, right? This is really what it formats out of that. And if I change something here, so if I make that a multiplier, it will change the indentation accordingly, right? And lastly, this is a macro, like a multi-line macro, and it will nicely format it, align, attach escape new lines. Not actually sure. I think Yeah, Google style I think prefers them aligned to the right, and I don't know what LLVM style wants, so I think it's still aligned to the right. But these are all flags we can just set. Right, we can also, need to save stuff. So now going back to my favorite file, sema.cpp. I actually found a case where I think pretending to have consistent formatting is really bad, right? So I found this call, and because I'm used to stuff being consistently formatted, I easily think that this is the third parameter to erase, right? Which it isn't. Right? In this case, there's no closing parenthesis here, and this bind first is actually the second parameter or third parameter to remove if. Right? And so using some consistent formatting but then not following it through is really bad. And if you format that with Clang format, it gets formatted nicely. So you have to remove if and the three parameters to remove if. Yes. And this I won't commit, if you add other stuff, right, it will reformat and find out the best formatting for it. So now it still can do it on the same number of lines, and at one point it will actually need to have another line, but it will still nicely align that so you can see syntactic entities quite nicely. Okay. All right. I can demo more later if you prefer, but I want to move on with the presentation first. Okay, so how can you use Clang format if you now desperately want to use it, which I could understand? You can basically quite easily integrate it with your editors, right? So it's all in the Clang format directory, which is part of the Clang repository. We have a Clang format.py, which is the Vim integration. You can just bind it on the key, like all of these contain instructions on how to use them. If you use Emacs, we have an Emacs integration, and it was also kind of nice if you work on Clang and LLVM, you can use this diff script. So you basically create a unified diff of your patch and pipe it into this script, and it will reformat just the changed lines in your patch, right? So it won't touch anything else on the file, but it will reformat what you have changed, so you can be sure that your changes are formatted correctly and you don't get nitpicked in the code review. Right? We also have a working Eclipse integration. I just don't know how to basically publish that. So if anyone knows anything about Eclipse, like I have a piece of code that is an Eclipse plugin and works quite nice. I have a basic hack for TextMate, and I think a lot of others should be quite easy because the binary is very easy to use. Also, if you write a refactoring tool or source translation tool, you can use Clang format's binary. It's in Clang format.h. Basically, we have only one function. We will add more functions, but we don't this is the only function we've needed so far. Basically, it's called reformat, which makes sense. You give it a format style, a token stream, so Alexa, and the ranges you want to format in this token stream. And it will give back to you a set of replacements, which basically just says, from offset with length, replace this with a certain new text. Right, and that should be basically all you need. I think we will very soon add a function where you just hand in a string and ranges, and it will give you this replacement object. Yeah, as I said, we happily extend the interface or welcome patches. So what you need, we can probably put it in there. All right, so where are we now? As I said, Clang format understands most of C++ and Objective-C constructs. With 3 style guides at the moment, so we can do LLVM, Google, and Chromium, although Chromium is quite close to Google, so that doesn't really count. And Clang format, but for quite some time now, can format all of its own source code, which is like a couple of thousand lines of code. So it should be fairly stable. And I think we fairly quickly reached the point where Clang format does way less mistakes than I do, and probably most other people do. So even if it occasionally does something wrong, it won't probably be much worse than if you did it yourself. Right, so what's next? First of all, we have a few outstanding bugs and formatting improvements that we want to fix. Then I think the most important part now that we are fairly stable is that we make the configuration easier, so that you could have a configuration file, for instance, in your project directory, and we'll set up the style you use. Right now it's all command line flags, and we actually don't have command line flags for specific style options. That was also something we need to add. We want to support more coding styles, just in general, more than those 3. And we haven't really thought about it, but it should be fairly easy to add coding styles that use tabs. Like we don't use tabs, so we haven't really thought about that. It should be fairly straightforward. What I don't fully know what we would do, there are coding styles that don't have a column limit. Maybe the answer should just be we don't support them, so they bloody get a column limit, even if it's a large one. Or otherwise we could just disable the line breaking. Like just use the lines as the user wrote them and just indent them. But I think that would actually diminish the usefulness of Clang format. We need to support a few missing C++ 11 features like lambdas, they kind of work, and trailing return types, they work but look ugly. And once we're done with all that, we want to go one step further and build Clang Tidy, which is not based just on Alexa, but it has full parser information, and it actually does non-white space changes. So we have a lot of coding styles, even in LLVM, like don't evaluate end every time through a loop. So it would be very nice if we had a tool that warns me about using stuff like this, right? So whenever you do it or try to submit a patch, it just tells you don't, right? But we also wanted to be able to automatically fix it, right? Because it's just not worth human effort to do this if there's a trivial source-to-source transformation. So we then build a source-to-source transformation tool, kind of, or at least a simple refactoring tool, which can solve cases like this, then run Clang format over it again, and end up with nice code that adheres to way more coding styles than just formatting. All right, thank you.
Any questions?
So for the Clang Tiny example you gave, what about cases where you actually do want to evaluate end because end changes inside your loop? And there's lots of other cases where you have a style exception that matters.
Yes, and you basically for those rules you need an escape hatch.
Yeah.
And I don't know what's going to be, like we've not looked at every, I think not all those rules will need one, but those that need one will need to add something, right? I don't know whether it's going to be an attribute or whatever, I don't know, or a certain way of writing the loop. But yeah, and that's just an example. Maybe that's one that's not easy to automatically fix. Might still be interesting to warn about it. But yeah, I think still you will need an escape hatch.
Yeah.
So you mentioned about sort of supporting more coding styles. How orthogonal is everything in the sort of code base? If I have a coding style that say doesn't put white space where all your other styles do, will that be automatically understood by the sort of line breaking logic and so on?
Right. So that's a good and painful question. We have basically sprinted towards getting everything, like every feature we need supported for the coding styles we have. It's already good that we have Clang or LLVM and Google coding styles, which are not equal in many respects. But now I think the next steps are going to be to refactor the code to actually be more orthogonal, so that we have specific style options that you could set for whatever you want for that. I don't think it makes sense just to randomly add coding configurations. I really think we should go ahead and look at existing coding styles and figure out where the differences are and what features we want to support, and then move towards that.
Yes.
Any other questions?
I kind of saw a bit of it when you were giving the example with this and then adding a few eyes, but how well does it work on code that wouldn't compile? Like kind of, would it correctly format a line which is in like a half-finished function or something like that?
It would, yes. We have spent quite some time. It's never perfect because that's actually a hard problem. It's also a good thing that we don't use the parser, because the Alexa always works, right? And so if the half-finished function is broken at some other point, we really don't care. We don't need it to compile. And I mean, the example I have here, right? This is just a random file where I did stuff, right? It doesn't compile anything. Nothing there would work. But if you have unbalanced parentheses inside your line, we now have programmed it to give up before doing something wrong. So if it doesn't do anything, you can probably figure out your parentheses. But yeah, that's probably something we can improve upon.
There is a use case for this formatting. For for example, if the official formatting in the source code is in a way, but some developer really wants to work with his own style because he's really used to it.
Yes.
And is there a way for this to say that when he works on his computer, he can do whatever he wants, but it doesn't change the style when he commits it or something like that? It's just like a temporary style.
I think that works to a certain extent. It doesn't always work because we do stuff like if you have a very long string literal, right, and that exceeds the column limit, we actually break it, and so we actually by now do some known white space changes, right? But we don't merge them back because that's a different operation, sort of like not as safe. And so you might end up with, so you can easily say, well, I work on CMA now, so change the formatter to have the code my way, right? Then so like change something and then set the style back to LLVM and format it back. Well, we have not investigated whether the end result will actually even closely resemble the original formatting, right? So it's possible, and we have thought about that, but we have not investigated a lot into it.
And another totally different question: do you work on formatting string literals, for example? Detecting that a string literal contains XML code and then reformatting it.
I have said that we could eventually do that, but that was more of a joke. So we do, like we won't, I don't want to implement an XML parser and formatter, right? But, I mean, why not? We do certain things inside string literals, right? So, for instance, if you have a log statement or a diagnostic, right, and you have a couple of string literals and some of them contain colons, right, Klangformat actually looks at those colons and will try to keep the next bit on the same line. So you can easily write something A colon and then the variable, and B colon and then the variable. And we'll actually try to keep them on the same line even if it could arrange them differently, right? So we started looking into string literals, yes. But really layout, sorry?
And comments?
Well, we've started on that. We break comments that are too long. And we think we might at one point even need a different mode for that, right? If you have a patch and you just want to format the patch according to the style guide, you want a certain set of transformations that are relatively safe, that don't change the meaning of your comment, that definitely don't change the behavior of the program or anything. When you are in the editor and you say, I need to reformat this comment, right, then you actually might want a certain set of extra operations that might be not as safe, right? But yeah, we're not that far with that thought.
Yeah, I was wondering, say I have a tokenizer for a different language than Clang currently supports, and in that language some white space has a meaning. How difficult would it be to connect it to?
Well, as soon as white space, like the fact that white space does not have meaning is sort of the fundamental thought we have, right? As soon as you can change the meaning with changing white space, you have to start over. I'm not saying it doesn't work, but I don't know. You can't format Python. It doesn't.
Yeah, that was.
Can you enforce C++ style of comments, for example?
What do you mean C++ style of comments?
Double slash over C style slash star.
Not yet, but that's definitely something we want to do at some point.
And when are you expect to have configuration files?
As soon as I have time to work on it, or as soon as we get patches. Yeah, I don't know, but it's definitely something we want to have this year, probably sooner than later.
Any more questions?
Any plans for Visual Studio?
For Visual Studio, do we have a Visual Studio plugin developer here? Because yes, we want to have Visual Studio, but
Yes, we do.
yes, we do. Okay, so yes, we have plans for Visual Studio.
No more questions? Okay, thank you very much. So don't forget, you have to be on the boat around 8 max.